To prove that this is a subset of this set, we just have to say X is an element in A and B. If X is an element in A and B, we can just rewrite that out. I mean, we're not changing anything. We're just saying X is an element in A and X is an element in B. What we want at the end of this proof, we want to say, therefore, X is an element in A union B. That's our goal. We want to show that this means that X is in A union B. If we have X is in A and X is in B, that means that X is in A and X is in B. What is that going to say about the union of those sets? If it's in one and the other. Yeah. If X is in A and X is in B, X is in both A and B. And what does that mean in a more mathematical term? If you combined them both together, would X be in it? X is in A union B. Now you might be wondering, we have an and here. Wouldn't that mean X is in A intersect B? Well, yes, that's true. But if something is in the middle, if it's in the intersection, that means it's in both A and B. Let me use a numerical example. If A is equal to 1 and 2, and B is equal to 2 and 3. Let's look at 2. 2 is in A intersect B, right? Because A intersect B is what's in A and B. And what's the only thing that's shared in A and B? Right. Now we look at A union B. What's the union of these sets? And even Faye can answer this one. What's the union of these sets? Join them together, unite them. It's 1, 2, 3. You're good, don't worry. Would you say 2 is an A union B? Yeah. So the same thing would go for X. So if X is an A and B, X would also be in what? You're done. That's all. Congratulations, you've just done a set theory proof. Wasn't so hard, was it? Yep. Oh, yeah. Yep. Mm-hmm. Now, why can't we say that A union B is a subset of A intersect B? Well, let's try our proof method before. X is an element in A union B. That means X is in A or X is in B. And we want to prove X is in A and X is in B. So X is in A and B. Now, why can't we say X is in A or X is in B is equal to X is in A and X is in B? Because it's simply not saying the same thing, right? Mm-hmm. Right. You could say, let's use another example, A union B is equal to 1, 2, and 4, right? A is equal to 1, and B is equal to 2 and 4. You can say that the union, 1 would be in the union of A, U, B, but 1 is not going to be an element in A complement B because there is no overlap. So A complement B would be what set? Sorry, the intersect. What would the intersect of these sets be? If there's no overlap, what is it? Empty set. That's what you call a counterexample. We've just proven with a set that something can be in A union B, but not be in A complement B. There we go.